Greeting, Earth scientists. Today we are going to discuss mountains and mountain building. Mountains are natural landforms that reach higher elevations. Generally, they have steep slopes and narrow summits. To be a mountain, you need to be at least 600 meters above the surrounding land. Now, mountains are built, orogeny is what it's called. Mountain ranges are a group of adjacent mountains that have the same structure, shape, and they were all formed together. The picture below is the Cascade Mountain Range, which was formed by subduction on the North America west coast. The Juan de Fuca Plate is subducting under the North American plate, causing uplift. They generally occur in belts. There's two major belts. The Circum-Pacific Belt is caused by the Ring of Fire, as it's called, in the Pacific Ocean. And then the Eurasian-Malaysian Belt runs across Africa, Europe, and Asia. So mountain systems are a group of adjacent mountain ranges. Examples: the Great Snokies, the Blue Ridge, the Cumberland, the Appalachians are all mountain systems. We do have several types of mountains. Folded mountains are caused by compressional forces. You can see synclines and anticlines causing the bending and tilting of the Earth's crust. A monocline is rare, but it's one fold. An anticline is like an A. Syncline is like a basin. Generally speaking, they form folded mountains. The highest mountain range in the world is caused by compressional forces, the Himalayas. When the compressional forces cause faulting, it's called a fault block mountain. Fault block mountains, the peaks are called horsts, and grebens are the valleys. Yosemite is an example of a fault block mountain. There's examples of some horsts in the image below in Nevada. Now, volcanoes are not formed by deformational processes, but formed by the buildup of magma and then lava, the magma that reaches the surface of the Earth. So volcanic mountains can develop on land or the ocean floor. The largest ones are found on divergent plate boundaries of the mid-ocean ridge. They're called shield volcanoes. The ones on land are far different because they're a basaltic type, or a granitic type. A basaltic type form on the ocean floor. The volcanic domes are more of the continental. Intraplate would be those huge stratovolcanoes that explode like Yellowstone, the supervolcanoes. Lava is magma that reaches the surface. Notice this image, you can see steam and volatiles venting off. So lava has a different composition than magma, although they come from the same thing. Low silica basalt found on ocean floor is fast moving and flow. Higher silica basalt found in continents, remember granite is higher in silica than basalt, they explode. And again, the volatile components come off of the magma as it seeps to the surface and becomes lava. We call the explosive portions pyroclastics. There's an image from the Philippines during Mount Pinatumbos eruption of pyroclastic material leveling the forest. They travel hundreds of miles an hour, these 500 to 700 degree, even closer or more when you get closer, causing great destruction. This image shows you an anatomy of the volcano and some of the igneous intrusions, like a laccolith or a dike or a sill. This image shows you the relative size of the types of volcano. Shield volcanoes are oceanic in origin. The other two are more continental margin and intracontinental volcanoes. Few ranges: the Andes, South America's longest range, caused by subduction. The Sierra Nevadas, those are fault block. You can see how they're jagged because of the compressional forces and the faulting. The Rockies, caused by uplift. The Himalayas, caused by continental subduction, the highest on Earth. The Appalachians, an old mountain chain. You can see how erosion has rounded them off and they're not jagged. They're not the high peaks anymore. They're covered in vegetation. The Alps, the great mountain range of Europe. Remember, the Mediterranean is closing and the Tethys Ocean Basin has been pushed into a landmass. The Alps are the result. Mount St. Helens, which is interesting, it exploded when I was in high school in 1980. One day you can see it was a mountain. The next day it was a crater. Kilauea on Hawaii, the most active volcano, has lava, basaltic. You can see it's the dark color, that's basalt rock, fresh basalt. Mauna Loa is the highest, or the highest from the Pacific floor mountain on Earth. So the big island of Hawaii is made of shield volcanoes. The Aleutian Islands, subduction up in Alaska. An archipelago is volcanic islands caused by subduction. The Cascades we mentioned before, caused by subduction. Crater Lake is a caldera of a volcano. Hawaii is one of the more unique areas, has a lot of calderas. And Yellowstone is that supervolcano because it's in the middle of a plate. Etna is Europe's most active volcano. With all this change, you would expect the Earth to constantly be changing, and it is, but those changes always balance each other off. Weathering balances with erosion. Uplift balances with subduction. So we have an isostatic system here on our planet.